Today, we are talking about speaker placement in a Dolby Atmos configuration, specifically a 9.2.4, which is what I have here in my theater room. Now, this is something that has caused a lot of confusion for a lot of people, and it starts with the explanation straight from Dolby, which is confusing at best and misleading at worst. It's confusing because they list all of these angles and lines and diagrams, and then it's misleading because the pictures aren't even consistent across, from one picture to the next. In one diagram, it shows that the Atmos speakers need to be placed in line with the mains. Not true. Don't follow that. And then also they show that the rears need to be equal distance from the main listening position as the mains. Also not true. Don't follow that. So today I'm going to break it down and give you a super easy, simple formula to follow to place your speakers, both the bed layer speakers and the Atmos speakers, in the best ideal configuration. If you can measure with a measuring tape and multiply two numbers together, you can figure this out. First thing we're going to start with is the center channel. Boom, right here. Now my center and left and right are behind my screen, so you can't see them. The center goes right in the middle in front of the main listening position. So wherever you're seated in the MLP, you want the center channel to be directly in front of you. Now, where to put the right and the left mains? It's super easy. You take a measuring tape and you measure from the center channel all the way up to the main listening position. Now, the main listening position is right here. It's out of the camera frame, but you can imagine where it's at. You measure that distance, and once you have that distance in inches, you multiply it by 0.58. So imagine it were 100 inches. 0.58, 58 inches. That gives you the distance from the center of the center channel to the center of the right channel. So if it were 100 inches distance from the center to the MLP, you would measure over 58 inches from the center to right there, 58 inches. What if it were 50 inches from the center channel to the MLP? Well, it would be 0.58 again, so it would be 29 inches over. Boom, right there. It's that easy. It's that easy. And then you do the exact same thing to place your left. It's going to be equal distant from there as it is from the center to the right. Now in a 9.2.4 setup, you're going to have obviously your mains, which we've already covered. You're also going to have a set of wides, and then you're going to have your sides. Let's start with the sides because those are the easiest. Now in my theater here, this is my main listening position. Right here, this middle chair right here. You want your sides to be directly to the side of your main listening position. Maybe slightly forward, maybe a few inches forward, but basically in line at ear level as the main listening position, right there. There is your side, right there. That's easy. Where do we place the wide? Well, we're going to use a formula identical for how we place the mains. And what you do is you measure from the main listening position right here over to your wall where you're going to place your wides. You measure that distance and then you multiply by, you guessed it, 0.58. So if it were 100 inches from the MLP to the wall, 100 inches times 0.58 gives you 58 inches. So you know that your wide needs to be placed 58 inches this direction from this point here. And then you place your wide right like there. And that's how you know where to put your wide. 0.58 of the distance from the MLP to the wall. Now, you're probably wondering, what is this 0.58? What does that give us? Well, when it comes to immersive theater, you need to think in terms of angles. Imagine that there's a bubble, a dome over you, and you want your speakers placed in such a way that it gives you maximum coverage all around you. Imagine if you put all of your speakers right over here. You had 8 speakers, 9 speakers, and they're all right here. You're just going to hear sound from that one direction. But if you take those 9 speakers and you spread them out and you distribute them evenly, you're going to have sound all around you, right? So that 0.58 multiplier that we've used to place these speakers, what that does is that places our wide at 30 degrees off of this distance, this location right here. 30 degrees from the MLP, this direction, that's where we put our wide. And then the distance, or the angle, I should say, from your wide to your left main, if you use that 0.58 correctly, it's going to be another 30 degrees. And then the angle from your left main to your center, 30 degrees. So now imagine, you now have perfect coverage. You have 30 degrees, 30 degrees, 30 degrees, right there. And that way, when something is panning across, the sound is traveling across your room, it's traveling an equal distance from speaker to speaker. You're not going to get like a big gap in your coverage where the sound is right here and then suddenly it jumps way over there. It's evenly distributed. So that's why that 0.58 is so critical for these speakers, because it creates that 30-degree equal distance between all of them. And then it does the same on the other side. 30 degrees, 30 degrees, 30 degrees. So we have covered the center, left and right mains, the sides, and the wides. Now we're going to talk about the rear or surround speakers. Now in a 9.2.4 setup, you're going to have 2 speakers that are behind the main listening position. How do we calculate where to place those 2 speakers? It's really easy. You measure from the main listening position the distance from there to your back wall, if the speakers are going to go on the wall. And then you take that distance and you multiply it by, you got it, 0.58. 0.58. And what that gives us, that number, then tells us the distance over from this point that's directly behind the main listening position. That's the distance from there over to where you place your speaker. So again, using our example, 100 inches, if you measure it, it's 100 inches from your main listening position to your back wall, multiplied by 0.58. You measure over 58 inches, and that's where you place your rear speaker. And then you do the exact same thing. You measure over that same distance over here, and you place your other speaker. And now you've got all of your bed layer speakers measured out. So now let's talk about Atmos or height speaker placement. This is an area that trips up a lot of people. It certainly tripped me up. When I was designing this theater, I did not fully understand how to place speakers. I'm sure if you've been paying very close attention, as I've gone around the room and explained how to calculate where to place the speakers, if you've looked closely, you probably noticed that my speakers are not placed very well. That's because when I designed and built this room, I didn't really truly know what I was doing. And I have learned a ton since I have built out this theater. But now it's built out and it is what it is. So, we live with what we got. Fortunately, and this is a big takeaway, hopefully, for you from this video. And the takeaway is, despite my very, very poor speaker placement in this room, it still sounds incredible. So there are a lot of things that you can do, even if your speakers aren't placed exactly right. There are a lot of things you can do to really make it sound amazing. Just off the top of my head, acoustic treatment. So acoustic paneling, absorption, diffusion, running your room correction software correctly, getting that all dialed in, all those things, subwoofer placement. There's a lot of things you can do. It doesn't all hinge on having your speakers, within, an eighth of an inch of where they should be. So if you have to move one slightly because the door's in the way or you've got a light fixture, don't sweat it. You can still make it sound really, really good. But let's talk about how to calculate the height speakers. Again, you start here at the main listening position. You measure from ear level to the ceiling directly over the MLP. You take that measurement and you multiply by not 0.58. I know you were thinking 0.58. You don't multiply by 0.58. You actually multiply by 0.7. And what this is going to do is this is going to create an evenly distributed sound array, starting with your side speakers up to your heights, and then the distance, the angle between the heights relative to the main listening position. So just trust me, use 0.7 for this. And then you use that number. So again, our hypothetical, say it's 100 inches, you multiply by 0.7, you got 70 inches. So you take that 70 inches, or whatever you calculate in your room, and then you measure out from that center point, 70 inches, and then you measure to the side 70 inches. And then you do the same for the other speaker. You go over 70 inches. That's for the fronts. And then for the rears, you do the exact same thing. You go up, you start there at that point, you go directly back 70 inches, and then you go to the side 70 inches for that speaker, and then to the side 70 inches for that last speaker. That will give you evenly distributed sound overhead. So I thought it would be helpful to draw out and calculate a hypothetical room. So I've got the walls drawn right here. Hopefully you can see it pretty clearly. And then this X marks the main listening position. So obviously the center channel is going to go directly in front of the main listening position. And then using this graphing paper, we're going to count the number of squares, or the distance, like we would measure in our own theater. Measure this distance here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we know that we take that measurement, so that's 10, multiply it by 0.58, that gives us 5.8. So then from this point, we go over 5.8, so it's going to be just under 6. So 1, 2, 3, 4, 5, 6. And then just a little bit to the left. I'm generalizing here. So it's not exact, but pretty close. And then we do the same thing for the left. We go over 1, 2, 3, 4, 5, no, 6, just a little bit less. That gives us our left, center, and right. Now, the sides, we know those are just directly across from the main listening position, directly to the left and to the right. Now we measure that distance, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 9 times 0.58, just a little bit over 5. So we calculate the location of the wide speaker to be just a little bit beyond 5. So 1, 2, 3, 4, 5, just a little bit beyond. And then we do the same thing with the right wide speaker. Now, for the surrounds, the rear speakers, we measure from the main listening position to the back wall. And that distance in this room is 1, 2, 3, 4, 5, 6, 7, 8. So we take that 8 and we multiply by 0.58. And we get 1, 2, 3, 4, just a little bit under 5. So we measure over 1, 2, 3, 4, 5, and then a little bit in. So mark that location for that speaker, and then we do the same on the other speaker. 1, 2, 3, 4, 5, and a little bit less. Now you can see, just intuitively, you can look at this diagram and see how evenly the speakers are dispersed. You have all of the holes, all the gaps. Like there's no wide gaps between speakers. The only wide gaps are the ones directly behind and to the side of the main listening position. But that's just because we're limited on the number of speakers. We only have 9 bed layer speakers. If we had 11 bed layer speakers, then it would basically have total absolute coverage. But because we have 9, we have to, compromise a little bit, which is fine. But you can just intuitively see how the speakers are evenly dispersed around the room using that 0.58 calculation. Now let's do the same thing with the height speakers. Now in this room I've drawn, you have the floor here, you have the walls here on the side, and then the ceiling on the top, and I've drawn a very rough image of a chair here in the middle, and we're going to assume that the main listening position is right here and the ear level is just at this midpoint right here. So we calculate that, or we measure that distance from here to the ceiling, which is 1, 2, 3, 4, 5, 6, 7. And then we take 7 and we multiply by 0.7. And that gets us 4.9. So just a hair under 5. So we count over, this is where we measure, 1, 2, 3, 4, 5, this speaker, and then 1, 2, 3, 4, 5, this speaker. And now we can see, looking directly at the main listening position, these are the side speakers right here, and you can see how these speakers are evenly distributed to create a sound, a dome of sound over the main listening position. These speakers are evenly distributed across where the ear level is right here. So that's a good visualization to see what we've talked about and why these measurements actually return good speaker placement locations for any room. It doesn't matter how wide your room is, how tall your room is, how narrow your room is. You follow this formula and it'll give you the best chance of excellent speaker placement. Thanks for watching.